Hey everyone, today we're going to do Chemistry Chapter 4, and this is a condensed version of Chapter 4, making sure that you guys have all of the information needed to move on to Chapter 5. So I've split this into 3 hopefully easily digestible sections. So first we're going to start off by talking about what is an atom. Now in junior high they've taught what the atom is, and today we're going to build upon it. So an atom is the smallest particle of an element. So again, atoms make up elements, and they retain their identity in a chemical reaction, which means, let's say if you have gold in a reaction, it's going to stay gold. It's not going to change. This idea of the atoms existing was first suggested by a philosopher called Democritus. It was later backed by a scientist with experimental evidence named John Dalton. Couple things about these two people is they described the atom the same way. They said the atom was first indivisible, and all that means is it cannot be divided. And then they said it was indestructible, which means you couldn't break it down. You can't just poof, gone. These scientists are very important about the evolution of how the atom changes, because we're going to later find out that atoms actually can be divided. So their idea right here in 1803 was that the atom was just a solid sphere. However, it was later stated and later proved by other experiments that atoms actually could be broken down, and they're just not as simple as a solid sphere, and they can be broken down into things called subatomic particles. And there are 3 types of subatomic particles we are going to talk about today. The first one is the proton, the second one is going to be called electrons, and the third one is called neutrons. These 3 are very important to know. They are going to play a key role in this chapter. So the first one we're going to talk about are protons. If you think of what's a pro, like a pro tip or you're a pro, this gives a positive connotation. So I always think of protons, you're on the plus. So these are positively charged subatomic particles, keyword positively. They are usually abbreviated with a P, meaning protons, and a plus sign, meaning they do have that positive charge. Couple things about the protons is their location can be different from the other subatomic particles. Protons are specifically found in the nucleus. And to define what the nucleus is, it is a positively charged area located in the middle of the atom. So protons are found in the middle of the atom, and actually, fun fact, protons are what gives the nucleus a positive charge. The other thing is the proton's mass. Proton actually has a relative mass of 1 AMU, and AMU is just atomic mass unit, so the atom's mass. And it is actually almost equal to the mass of a neutron. Some books will say that it is equal, so almost equal is the verbiage that we tend to use. The second type of subatomic particle are electrons. Electrons are a little bit differently than protons. They have the opposite charge. Instead of being positive, electrons are negatively charged. Think of like electricity, negative charge. This is abbreviated with an E, which stands for electron, and then a minus sign to indicate it has that negative charge. Electrons are not found in the same location protons are. Electrons are actually found outside of the nucleus, and the other thing about electrons that make it a lot different than protons is that their mass is extremely small. It's smaller than both a proton and neutron's mass, and in fact it's about 1/1840 the mass of it. So it's extremely tiny and does not contribute that much. The last subatomic particle is called a neutron. Neutrons, I think of the word neutral, neutron. These are subatomic particles that have no charge whatsoever. And for, I just scribbled down there. For its abbreviation, it's an N, meaning neutron, and then a little 0 or O looking thing to mean no charge or zero charge. Neutrons are actually found in the nucleus with the protons, and because neutrons have no charge, this still makes the nucleus positively charged because of those protons that are located there. The other thing about a neutron is it does have a relative mass of about 1, which is about the same mass as a proton. So you're going to find out that most of the mass in the atom is right there in the middle. There's not a lot of mass on the outside. Now remember, we said that Dalton and Democritus said that the atom was a solid sphere, but these basically understanding of subatomic particles allowed us to evolve the atomic model from what it first was. And one of the first people to change the atomic model was J.J. Thomson, because he actually discovered the electron. He came up with a model called the plum pudding model, where he basically said that this whole blue outside was positively charged. So blue was positively charged, and that there were just kind of electrons stuck in this lump of positive charge. And we will find out our new model was determined by Ernest Rutherford. He actually proved the plum pudding model was incorrect. And his model suggested the first existence of the nucleus that we talked about on previous slides. He said that protons and neutrons were located in the middle of the atom, and he called that area the nucleus. And he said that electrons actually occupied the space outside of the nucleus. And he also mentioned that this spot right here in the middle was where most of the mass was, and the rest of the atom was actually mostly empty space. In Chapter 5, we're going to learn that this sometimes was called the planetary model, but this is our current model that we use in chemistry. Again, nucleus is in the middle, it's positive, electrons outside of it. And that's the end of this first mini lesson. Let me know if you have any questions, and I hope you have a good day.